This is a SolidWorks 2011 wheel rim tutorial from Chapter 3 for the MET 100 Spring 2013 curriculum. So this video is going to cover a couple of concepts, starting with the dynamic mirror tool. We're going to put the offset tool to use as well, and we're going to look at a couple of different constraints such as equal, concentric, and symmetric. Later on, we're going to look at mirroring whole features rather than just sketch entities, and also look at an interesting use of the convert entities tool to quickly create sketch geometry from existing features. A few general tips you're going to want to keep in mind for this video are to uncheck the Enable On-Screen Numeric Input box in the System Sketch options. This frees up the A key to switch between line and tangent arc when you're using the line tool. And so basically this makes it easy to draw curved, smooth profiles in your sketcher. You also may want to create a template part based on a common set of units and materials and such. So basically what that'll let you do is skip that whole setup process that you go through every time. So here I've created a simple part, and I can say, for example, if I want to specify a material, we'll choose a common one here. A lot of parts are made out of steel, so we could do hot rolled bar. Apply this, and we'll notice that I've also switched my unit system to IPS in Document Properties Units. So I can save this as a part, or I can save it as a part template. And so that's in my Save As menu. There is this entry, part templates.prt. So if I save it as PRT dot, it automatically switches to my SolidWorks 2012 templates folder, and here I could call this something like MET 100 part. Then when I go to create a new part, it appears as in this menu. I create a new part, and you can see we have that material. So you keep that in mind if you want to create a part that has standard properties. Looking now at the drawing for this part, we have the main shape looks like this on the side, which we can see it's a three sort of winged rim, and we have a couple of through cuts, which are these features here. We have some webbed features here as well, and finally the hub in the middle. In the detailed sections here, we're looking at section A, with additional focus on B and D. We're going to be using them to create each of these features. Now, this information given here should be enough to create the tire, but the rim, but it's presented in a way that it can be a little bit tricky to follow sometimes. And for example, these angles here may not necessarily be the most logical way to dimension these features. So you have to be very careful about how you create these sections to make sure the shape is correct. So looking at the first feature, we're going to start with Revolved Boss, or base, and we're going to start on the front plane, and you can, depending on what you want, choose in any of the planes to start from, but the front plane is convenient. We're going to start by sketching the lower edge of that outer rim, and this is because we're eventually going to use offset to create a duplicate of that shape, but we don't want to complicate the sketch too early. So the process is we're going to start with the cross center lines. We're going to use the dynamic mirror tool to enable us to quickly create the other half of the sketch. And then we'll just use the line tool to draw the feature. So we're here in SolidWorks window. I'm going to sketch on the front plane. And as I mentioned, we're going to create a center line horizontally, a center line vertical, and if you're so inclined, you can sort of pre-size these shapes to be about what you want. Sorry, that's double what I want. So it doesn't actually matter what the non-dimension sizes are, but having everything sort of line up in the beginning can save you some trouble. So we can see also that the center lines are coincident with the origin. and horizontal and vertical, and that produces, the result is we have black lines here, a black point at the end of each line, and just blue points at the end. So what that means is we can stretch the length of these center lines to whatever we want, but the orientation or this base won't move. The next step is to enable, in our sketch tools, we want to enable dynamic mirror. So with dynamic mirror on, we just have to specify the mirror plane, and then we'll have these two dashed shapes that indicate that the mirror tool is enabled. Now, as we start to draw our feature, so as I draw my line out, you'll see that my feature is mirrored to the other side. So then I'm going to hit A to switch between a tangent arc and a line. And you can see I hit A again to switch back and forth, so it's this continuous toggle. One other feature I'd like to point out is that if I start, it is context dependent what feature I get depending on where the mouse is. So I'm in line mode right now. I hit A, I switch to arc mode, but notice that the arc is perpendicular to the line. If I switch back here, however, it's tangent, so I can get both depending on what I want. Anyway, following the tire section, we're going to draw a quick arc section. We're going to draw a tangent line off of that, hit A to switch back to arc. We're going to draw a line that we want to be tangent, which is a little tricky to lock into. Hit A again to draw another tangent arc. Have another line coming up that is tangent. And finally, an ending arc. Now at this point, I want to point out that this sketch is relatively unconstrained. You'll notice the end here can sort of be bent over, but we know from our rim that these points need to be vertical. We can see that in our drawing here. It's a bit hard to see, but this edge here is parallel with this direction. So that means that this point has to be tangent to the horizontal line. So the easy way to do that is to select these 2 points using Control, and then we click vertical, and that locks them vertically so that this feature now, it can grow, but it doesn't change orientation. So at this point, the next step is going to be to start adding dimensions and constraints since we've created the basic sketch, and that's going to be primarily in Detail B. So if we've been disciplined about how we've been drawing our sketch, it'll look similar to this, maybe slightly different. So we can start adding the dimensions that won't really change much first. So that would be these horizontal distances. We've got the width here that's 1. We've got this size that's 0.7. So by using Smart Dimension, I can quickly add 0.7 on that part and 1 here. Sorry if I said 0.1 before. And so now the sketch hasn't fundamentally changed in shape, but we now have a few more constraints applied. Similarly, we can apply these height constraints. We have 0.335 each between the bottom edge, basically between each successive step. So that's going to look like, from our Smart Dimension tool again, we want to click on the bottom edge, select the upper edge here, and notice I've selected the edges, not the points. You can do either. In some cases it would probably be fine with the points, but the edges tend to make the sketch tool a bit better behaved, just from a user perspective. So I place that down. We can see it starts at 0.8 something, so I want 335. And without a giant change in the sketch shape, I've managed to constrain this additional dimension. At this point, we can see that our angle here is also similar to 130 degrees, so this might be a good time to click these 2 features and constrain the angle as well. So now, and of course this is sort of goofy in how it's been placed. We've got this vertical angle thing going on. And you'll notice that when I added that constraint, we had this tangent solution that isn't really what we want physically. I'm going to zoom in on here so you can see what's going on. This zigzag happens because basically the solver is too unconstrained. It permitted the radii to get too big, and so they actually overlapped each other. despite still satisfying our constraints. Now, all is not lost if this happens, but you have to be able to recognize it. Usually it's enough to just drag the feature towards what you want, and then you can kind of manually restore that shape with a quick flick of your mouse. So we're going to carry on dimensioning. We can now specify the other height, 0.335 again. And here we kind of have the same problem, and the culprit is that, again, that these radii are a little bit too big and a little bit too unconstrained. So it's somewhat free how you do this order here, but you just have to remember that whatever change you make, you should try not to make too big a change to the shape of the sketch at once. So my next step, for example, is going to be to add this radius dimension. So the radius from that drawing is 0.2, and we know also from the drawing that our these two radii here, the bottom radii, are going to be the same as well. So we can specify that by holding Control, selecting both of them, and then once this properties window pops up, I just click equal. So now this, we can see, of course, these are slightly better behaved. I can do the same for these inner radii, and now our sketch looks slightly more like what we want. I'm going to add the angle constraint at this point, 130, and things are starting to fall into place. I will add the width dimension, which is 2.125, here rounded to 2 decimal places. And now things are starting to fall into place. It looks pretty much like the final shape. I'm then going to add the overall height dimension by clicking the the bottom of this feature and the center line, and moving the mouse past the end, I can get an overall diameter rather than just a straight distance. And I'm going to make that 17. Now we can see that all of our constraints are satisfied. Everything is black, and so nothing can move around, and we're ready to draw the second half of the profile sketch. So we've done, so far we've seen the lower edge of the profile. We've applied the constraints in the appropriate dimensions, and so now we can add this part of the wheel here with the width of 0.5, width of 3, and then the overall diameter here of 5 inches. So again, keeping that dynamic mirror enabled, we can quickly sketch this out. All I'm going to use is just the line tool. I'm going to pick a position approximately in the middle, draw downwards, preserving, you can see that yellow icon that says vertical. I'm going to preserve my horizontal and vertical constraints and close the shape at the origin. So now that I have that shape with the appropriate constraints, I just need to add a few more dimensions to completely constrain this. I can dimension between here to be 0.5. I can dimension the outside to be, and here this actually highlights an important problem. If for whatever reason this line doesn't stay vertical, you'll get, instead of a linear dimension, you'll get an angle. And this is a sign that something is off with you've forgotten a constraint somewhere. So we can quickly fix this. If I delete that dimension, all I have to do is get out of Smart Dimension, select the appropriate edge, and make it vertical. And now this is locked to vertical, and our mirrored side is symmetrical as well. So I can then switch back to Smart Dimension, give this an appropriate, actually here I will, instead of that, I will choose this edge and the center, and now I can specify our diameter to be 5. Then I'll specify the width here to be 3 as per our drawing. Now once again we have this completely defined sketch, and so we're looking at, there's a few more steps before we're ready to revolve. You'll notice the sketch isn't whole yet. We still need to apply the offset, but all we need to do there is click offset, select chain, and then select the first in this line, and you can see that it understands, it propagates along these tangent edges to produce this full edge. We want a thickness of 0.1, and then we just want to cap off in our line tool, cap off the ends here to to close the section. We can see that our dynamic mirror tool has provided that for us. Okay, so with that, we're going to, in our last step before we revolve, open up, by cutting away these two lines, open up the section between this part so that we have one closed section to revolve. Then accept it. We select our center line, the horizontal center line, and now we can revolve the part. You can see the preview, which I'll then accept to create our basically our wheel blank.